Welcome to Bugged Out, the bite-sized podcast where we explore the art and science of functional verification and how to get the bugs out of the world's most complex chips. Hi, I'm Harry Foster, your host. This podcast was born from a simple idea. Every chip has bugs, and the real challenge is how fast we can find and fix them. With Bugged Out, my goal is to bring you candid, focused conversations with the people shaping verification today, from engineers, researchers, tool makers, and thought leaders. So you can hear what's working, what's challenging, and where we're headed. Today, we're diving into a topic that keeps a lot of design teams up at night, timing constraints. With me is Chandu Challapalli, Solutions Management Director at Siemens EDA, and author of the recent white paper, A Guide to SDC-Based Timing-Intent Verification with Questa One. If that title sounds a little intimidating, don't worry. We're going to make it fun. We'll talk about why SDC verification matters, how Questa One is changing the game, and what it means to finally get timing right the first time. Chandu, great to have you on the show today.
Harry, great to be here. Really looking forward to discussing the topic of timing intent verification with you.
Before we dig in, tell me, how did you end up in the world of timing intent verification? I mean, was it curiosity, accident, or maybe too much caffeine?
Caffeine was involved. I started my career in place and route before moving into verification. So I've seen this problem of timing verification from both implementation and verification. In implementation, SDC is the foundation for static timing analysis. And what you're doing in that area is trying to capture the intent of the design and verify and design and implement for it. When I moved into verification, I noticed a gap between design and verification when it came to an SDC. The intent is captured, but not always fully verified. And for me, as the customers are looking for this answer to confirm for themselves that their design intent in the SDC is truly fully verified, and my curiosity and my experience in that background naturally drew me to that area. So caffeine plus curiosity plus a customer need that I'm trying to help with.
All right, I love that. Now, if you had to explain what you do to someone outside of our industry, maybe like at a backyard barbecue, how would you describe SDC verification in a few sentences?
SDC verification is the process of verifying that the chip is performing at the frequencies that it's designed and intended for, with the exceptions that are allowed in that particular design. And so an SDC is a complex file with information that captures clocks, that captures timing exceptions, it captures any other timing-related constraints that are expected to be honored in the silicon when the chip is fabricated.
That's a great description. Your white paper does a great job showing that SDC files aren't just boring, setup scripts. They actually define how the chip experiences time. For listeners who haven't read it yet, what would you say are the top 3 takeaways from your paper?
You're right, Harry. The white paper is trying to change how people think about timing constraints. If I had to capture the 3 takeaways, the first thing I would say is that SDC is no longer just a setup script. It is not a side file that is required. It is a primary first-class citizen in the design process. So that's the first idea that we're trying to stress. The second thing is that design teams check SDCs, but they check it too late in the design process. And at that time, it's very time-consuming, risky, expensive to solve for problems. So the second point of the white paper was to stress on the importance of doing SDC verification early in the design cycle, as early as to do it along with RTL as it is being developed. And then the third one is to do this verification, we of course need some solutions, a product. And the third point is Questa One SIM brings that structure and automation to the process of design verification. So we're combining static checks, dynamic checks, coverage, and all of that in the same solution from Questa One. And so that allows for the complete solution there. So those are the three takeaways.
You also emphasize that both under-constraining and over-constraining can create problems. While under-constraining hides violations that pop up in silicon, over-constraining burns area and power. Why is this so hard to get the balance right?
You're putting your finger on the problem that the customers deal with every day. How do you get that balance right and why it is important? If you're under constraint, like you said, we have a design that is inefficient, has wasted silicon area, and ultimately is an inferior product in the market. And so no customer wants to do that. But if you go the other end of the spectrum and you over-constrain, it will start to work too hard. You start burning extra power to extract that additional performance boost, and that inflates the design, adds unnecessary buffers, and there's a cascade of bad things that happen from under-constraining. And you end up with a delayed schedule with a product that is unrealistic to what the market needs. And you potentially would even miss the market if you start to design for an over-constrained product. So those being the bookends, customers are always trying to find that fine balance. How do you constrain it just right to make your product a differentiated one and yet be able to do it with the PPA that the market requires in the time that the market is expecting the product? This is where SDC verification comes in. You now are able to check and really match the design's behavior to your RTL and then commit them and really accelerate that process of finding that sweet spot. Another side tangent to that same challenge is the challenge of keeping RTL and SDC in sync. As designs evolve, when RTL is very early and immature, you want your SDC to be somewhat relaxed. And as the RTL matures, you want your SDC to mature along with it. And that's a fine balance to achieve as well.
Let's talk about real-world SDC mistakes. Because engineers secretly love a good timing horror story. What are some of the most common pitfalls you've seen?
The easiest one is a missing clock, right? I mean, that's the most common one, the most obvious one that a lot of people trip over. Easy to find out, but you have a missing clock in your SDC, that's going to hide an entire part of your design from being seen in timing analysis. Right? But a more complex one, a more subtle one, which can hide real bugs in the design, are timing exceptions, false paths, and multi-cycle paths. And in these cases, the engineers are marking certain paths as false based on their understanding of the design. But if they're not constrained accurately, you end up either masking the design or exposing the design to timing challenges that don't need to exist. Another one is legacy constraints. And believe it or not, this happened just yesterday, literally. We had a customer who swapped their IP from one to another, but their SDCs were a carryover. And the interesting thing is they had objects in the SDC that were found in the old IP, but don't exist in the newer IP. This now leads to a functional bug, very subtle, and found very late in the design process. And these are the kind of things that happen all over the place, right? These are not unique challenges. Again, this is where Questa One can come in to find these kind of issues very early, spot these missing clocks, spot these unused or invalid exceptions, and being able to measure the correctness and accuracy of the SDC.
Thing I really liked about your white paper was the idea that timing constraint should be treated as verifiable design assets, not just a file someone wrote months ago and forgot about. Why is this shift in mindset so important?
It definitely changes the dynamics. And as you can imagine, different companies and different customer bases deal with it differently. But always the end result is a positive net gain. And traditionally, timing issues were back-end related. Back-end team discovered them late in the flow usually, and then the fixes are expensive, they're stressful. We're trying to do patch-ups in implementation while trying to mimic the equivalent changes in RTL and so on and so forth. When you start verifying these constraints early, the conversation shifts. Now both back-end and front-end teams are in sync. They want to make sure that they have the same understanding of the timing intent, And a lot of our customers are now asking for this active conversation to be enabled. Like I mentioned earlier, this need for SDC verification is coming to us from several of our customers now. They are asking for a left shift of take it something that's usually done in implementation, do it in verification, make sure that the solution in this area allows for both teams to talk to each other in a cohesive way. Right? And that's the value proposition here. We really want to bring back-end and front-end teams together, and our solution is allowing that constructive conversation to develop and be refined using Questa One Sim.
If we look ahead a few years, where do you see timing verification going? What's the next evolution of this get timing right early movement?
I think the evolution is to make it a continuous effort, not a static or a step function. I really believe that in the future, we're going to have verification and SDC development be done in a synchronous manner, in an intelligent manner, eliminating the need for human errors in the process, eliminating the blind spots that exist, and so on. Today, we're verifying early, which is great. That's an improvement over what we were doing till now. But going forward, how do we make sure we can use AI and AI agents to watch the system, watch the development of RTL, watch the changes in specifications and requirements, and actively suggest constraints that need to be added, flag inconsistency in those constraints. These kind of things almost start to think of it as a timing constraint assist flow, where the system is learning and evolving with the design, and your RTL and SDCs are evolving in a synchronous manner. I see that as an evolution. I see a tighter integration between verification and implementation in this area. With Questa One, we're bringing functional and structural together. In the very near future, I see the ability where this flow has implementation awareness to be able to flag inconsistencies or constraints that will really hamper implementation and have those be flagged earlier in the flow as well. And we can do that by defining metrics that are measured during verification stage very early in the design process that allow for the insights into what happens in backend and how to react to them. So the net of it, I think the industry is heading towards a smarter, more connected, more proactive timing intent verification flow. And we started the journey with Questa One, and I believe we will evolve into a much more automated, autonomous flow for this part of the design process.
Chandu, this has been fantastic. Thanks for joining and sharing your insight on how to keep timing clean and constraints smarter.
Hey, it's been a pleasure. Really insightful questions allowed for us to communicate the advantages of timing constraint verification. And I hope that the users will be able to find this podcast interesting and also be able to refer to the white paper that goes into more details about our technology and how we can help our customers deploy these solutions on their network, on their designs. Been a pleasure, Harry. Thank you.
For our listeners, if you want to learn more, be sure to check out Chandu's white paper, A Guide to SDC-Based Timing-Intent Verification with Questa One. The link is in the show notes. Until next time, keep smashing those bugs.